Hey guys, this is a video in my MATLAB tutorial series. In this video, we will be discussing lookup tables in Simulink. In a previous video in the MATLAB tutorial series, we have gone through an introduction to creating models in Simulink. If you haven't watched that video, it will be linked in the description. Without further ado, let's jump right into it and look at some lookup tables. As a reminder, in order to launch Simulink, you can type in Simulink in the MATLAB command window and press enter. Alternatively, you can click on the home tab in the tool strip and click on Simulink. Either should be just fine. Once Simulink is launched, you should see a screen that looks like this, and we're going to go ahead and click on create a blank model, and then a blank canvas should come up. We will click on library browser and then click on lookup tables, and we're going to drag and drop a 1D lookup table onto the blank canvas. Many of the other types of lookup tables will make sense once we understand what a 1D lookup table is doing. What is a lookup table? A lookup table is a Simulink block that takes arrays of data and maps input values to output values. When an input value is given for the lookup table block will return a corresponding output value. The 1D lookup table takes one input. As you can see, it only takes one input, and it returns one output. Let's double click on the block so we can edit the block parameters. And you can see that the number of table dimensions is 1, since this is a one-dimensional lookup table, but you can increase that. And then we're going to leave a data specification as table and breakpoints. And breakpoint specification, we're going to leave it at explicit values. Next, you'll notice that we have two fields, table data and breakpoints 1. The table data field is your output array, and your breakpoints 1 is essentially your input array. If we had a two-dimensional lookup table, let's go ahead and change this, you would have breakpoints 1 and breakpoints 2. But we'll look at that later. So let's change this back to 1. So we have table data and breakpoints. Let's say I have an output array that goes from 2 to 12 with an increment of 2. So it looks like this. It starts at 2, ends at 12, and goes up by an increment of 2. That's my output values. Now, what are my input values? Let's say it goes from 1 to 6, and we're going to apply this, and immediately after I hit apply, you will see that the graph or the plot inside the lookup table block has changed. The block will always look like a map or a graph of table data versus breakpoints. So this is a line. You can think of your breakpoints on the x-axis and your table data on the y-axis. So the x values are going up from 1 to 6 with an increment of 1, and your table data or the y-axis is going up from 2 to 12 with an increment of 2. So when your x value is 1, your y value is 2. When your x value is 2, your y value is 4. So essentially what we're going to hit OK. Essentially what we're feeding into this as an input is what is the X value, or what is the breakpoint value that we're looking for. So we're going to go to library browser, go to commonly used blocks, and go to constant and drag that in, and we're going to connect it. And we're going to open library browser again and go to sinks and include a display block so we can see what the output value is. In application, in a model, you might not directly have this go to a display. You might have this being used for a particular model. So it might go to whatever the output value is, it might be fed into some other component. So anyways, when we have our input as 1, we know the output should be 2. So let's go ahead and run this simulation. And we get 2, and that's what we were expecting. So if we say that our input is 2, we should be expecting 4 as an output. And that's exactly what happens. Similarly, let's say that our input is 6, then our output should be 12. And that's what our data tells us anyways. Now you might be wondering what happens if the arrays are not the same dimension. Let's say we have this as going from 1 to 7. Apply. Immediately you'll see that we have a question mark inside the 1D lookup table block. And that's signaling that something's wrong. And typically it could be that your array dimensions do not match, and they must match. Let's say in this current state we ran this, it's not going to work. Instead you're going to get some error. So just make sure that it matches. So let's change that back to a 6 and apply. Immediately it works. In most cases of using lookup tables in your models, you will probably be using some experimental data. For example, let's say that we have data for engine torque versus engine speed. I have made up some data. This is, I don't have actual data available, so I made up some data based on whatever I could find online and modifying it myself. Just so we have some unique numbers. What you would want to do is let's clear away everything. So now we have nothing in the workspace. Let's go ahead and run this. Click on editor and run. So we have run this. What's essentially going on is engine speed is going from 1500 to 5500 with an increment of 500. So let's open up the array, and we can see that it goes from 1500 to 5500 with an increment of 500. So we have a total of 9 elements. Similarly, in the engine torque array, we have 9 elements. So each engine torque value corresponds to an engine RPM value. So once again, the array dimensions match. 9 elements in this array and 9 elements in this array. Also, you'll notice that I have plotted engine speed and engine torque. So this is engine torque versus engine speed, and this is what the plot looks like. When we put this data in the lookup table, our breakpoint will be engine speed, because that's what we will feed into the lookup table block so we can get an output of engine torque. Essentially what the lookup table will do is it will plot engine speed on the x-axis and engine torque on the y-axis. So when you give it an input value of 2000, for example, it will know that the output value is 115.4. Similarly, if you set 3500, it will know that the output value is 115.5. So let's go ahead and enter these variable names into the parameters for the lookup table block. And make sure you run your script first. So I already ran the script. So here, instead of manually typing in arrays, I'm going to say engine torque. Make sure you spell your variable names exactly as they appear in your script. Discrepancies could lead to errors. So once I click apply, you'll see that this shape looks exactly like the plot I made here. Because what the lookup table block is doing, it's plotting the breakpoint and it's plotting the table data. Okay, so we're going to click OK. Now, since our breakpoint is engine speed, we're feeding engine speed as an input to this block, and we'll be getting engine torque as the output. So let's choose a number. We'll start with the first value, 1500. So the output should be 98.3. So let's go ahead and do that. So we're going to type in 1500, apply, OK. And when we run it, we should get 98.3. And that's exactly what we get. Let's try 2000, apply, OK. Run it, and we get 115.4. And if we look at the script, the second value is 115.4. And that corresponds to 2000 RPM. And the engine torque values are in Newton meters, by the way. You might be wondering, well, those are explicit values, 1500, 2000. They're explicitly defined in the breakpoints array. What about something like 1700 that's not explicitly defined? Does that return a value? Let's try that. So apply, OK, just put 1700 in the constant block, run this, and you'll notice that we get 105.1. What MATLAB was doing in this instance is it's using this block and it's interpolating between RPM values of 2000 and 1500. So if you look, 1700 would be approximately here, and that would be a little over 105. And if you look at the value here, that's what you get. So between your explicit data points, MATLAB interpolates to give you output values or other inputs that aren't explicitly defined. This can be very useful in certain scenarios where you might need MATLAB to interpolate for you. The other thing that we might want to discuss is when to use a two-dimensional lookup table or a lookup table with even higher dimensions. Let's say we have something like this, where we need two inputs to get to our output, such as pressure and temperature. A good example of something like this would be a steam table and thermodynamics. I put in arbitrary values in different spaces, like 1, 2, 3, 4, all the way up to 16. But you might actually have data for these values. My pressure is going from 135 bar to 150 bar. And my temperature is going from 10 degrees Celsius to 40 degrees Celsius. So in order to get a data point, I need to know both pressure and temperature. For example, at 145 bar and 20 degrees Celsius, my answer is 10. But even if my pressure is 145, but my temperature is 30, my output changes to 11. So this would be an example of where you would want to use a two-dimensional lookup table. And let's go ahead and do that. So here, I'm going to just type them out instead of having it on a script. I'll type in the data directly into the parameters here. So I'll change the number of table dimensions to 2. And immediately you'll see that I have breakpoints 1 and breakpoints 2. We'll get rid of this. and we'll get rid of this. We'll also get rid of this. So we're going to type in, we're going to have breakpoints 1 be our pressure, and our pressure goes from 135 to 150 with an increment of 5. And then we're going to have our temperature, and temperature goes from 10 to 40 with an increment of 10. So it's just saying that we start at 10, end at 40, and go up with an increment of 10. And here we're going to say we start at 135, end at 150, and we go up by an increment of 5. Now, when you type in table data, one thing you have to be careful of in this two-dimensional lookup table is that we need to specify that we're in where the rows end. So for example, we have 1, 2, 3, 4 in one row, we have 5, 6, 7, 8 in another row, and we have 9, 10, 11, 12 in another row. So we're going to say that we have 1 to 4 in one row, and then we're going to have a semicolon to denote that that's the end of that row, and we're going to a new row, and then we'll go from 5 to, and you'll see that we end at 8. And once again, we'll have a semicolon to denote that that row is done. And we'll go from 6 to 12. As you can see, this row goes from, not 6 to 12, 9 to 12. And then we'll go from 13 to 16. Let's make sure I didn't make any silly errors anywhere. 1 to 4, 5 to 8, 9 to 12, 13 to 16. So now we can click apply and hit OK. Now, one thing that you'll see is we have U1 and U2. Let's open up the parameters again. U1 corresponds to breakpoints 1 and U2 corresponds to breakpoints 2. Your U1 must be a pressure input and your U2 must be a temperature input. So under U1, I'm just going to name it pressure, and it's in bars. And here, I'm just going to copy this block and then paste it here, and then rename it to temperature. And it's in Celsius. Okay, so just let's double check. Yes, breakpoints 1 is pressure, and then breakpoints 2 is temperature. So let's see how good our table is. Let's try to find a value. So 140 and 20, that should give us 6. So we'll say pressure is 140 and temperature is 20. When we run this, we get 6 as we expected, and we can try that for a number of different values. And if we do 140 and 30, we get 7 as expected. Using a similar logic, you could use lookup tables with higher dimensions. That's it for the essentials of using lookup tables in Simulink. I hope this video has been helpful in some way. If you haven't already, please subscribe. Check out other videos on my channel, especially the MATLAB and Simulink tutorial series, as well as the graphing and scientific calculator tutorial series. Comment below any topics you would like to see covered in future videos. I hope you guys are staying safe and healthy. Until next time, take care, guys.